Happy Tuesday, everyone. Thank you for joining the Enverus team today for our webinar going over renewable project siting and design within our tools. My name is Jim Schumacher. I'm a technical advisor over here, and I'm joined by my colleague, Angelique Ezeki, a product manager of the pvDesign tool. Today, we're going to be diving into our tools, Prism and pvDesign, to show you how we can support your efforts of bringing renewable energy projects from conception through to the engineering, design, and optimization stage while executing quickly, efficiently, and effectively. On the project siting side, we're going to cover power market conditions, some infrastructure layers, competition projects, as well as land suitability analysis in order for us to drill down into a particular project location. Once we find that ideal location for our project requirements, we're going to use data found to execute an optimized engineering design and energy yield model that's going to provide us with over 300 different export documents. Some of these documents are things like SLDs and layouts, system design reports, bill of quantities, financial analysis, and so many more. During today's call, please feel free to add any questions into the Q&A section of this webinar. We're going to set some time aside at the end to answer any of these questions that you may have. To kick us off with the project siting portion of this webinar, let's set some bounds around what we are looking to accomplish. For our project location, let's look for some prime opportunities for 50 plus megawatt solar plus storage facilities in deregulated markets. With the recent incentives of the Inflation Reduction Act, ideally we should be finding a site that's part of an energy community and also has minimal environmental impacts during the permitting, construction, and operational stages of the project lifecycle. To prospect for these potential project locations, we will use Prism to ingest and analyze all of the relevant information. This platform maps out the data so that you can understand exact locations of information, as well as allows you to build out charts and visualizations so you can understand all of the variables around a given project site. As I drop this edit order layers dropdown, we'll see some of the data sets that we'll go over today. Currently displayed on our map is our power generation facilities. What we're doing is we're tracking any facility half a megawatt and above and in front of the meter, and then collecting granular information about that facility. We'll look at things like the project timeline, the supply chain entities involved, the point of interconnection, as well as all of the regulatory tracking for that generation facility so you can understand who's doing what, where they're doing it, and when it's going to come online. We also track things like production of those operational facilities, and then a full discounted cash flow economic model for all of our wind and solar facilities across the US. Moving down the list a little bit, we have our substation and transmission infrastructure. We're mapping out any transmission line, and then for substations, we're locating where all of those are and then actually tying back the generation facilities based on that POI to show you what the substation level saturation is from a project perspective. We're also mapping out our locational marginal pricing data on both the real-time and the day-ahead market and aggregating those values over different timeframes. We're looking from the past 1 week all the way to the last 5 years of data so you can run analytics, understand which locations are actually going to be the best to interconnect at. The next data set here, we have our parcels data set. We're mapping out surface ownership across the entire United States and then actually running buildability calculations on that land, taking into consideration things like the slope, the floodplains, the wetlands, the canopy coverage, some critical endangered species to give you that view of what piece of land is going to be the most suitable for your actual project. We also take a look at the energy communities from the Inflation Reduction Act, where those coal communities are, the EPA repowering sites, and then the utility scale brownfield sites as well. So you can overlay all of these different data sets on to really make the best decision on where you want to move forward with the engineering design of the facility that you're looking to build. Apart from those power data sets, we also bring in some traditional oil and gas infrastructure information. So as you're developing in those regions where there's heavy oil and gas activity, you can analyze things like the upstream, downstream, midstream facilities and understand exactly what the constraints are going to be around a given site that you're taking a look at. Since we are looking for sites with a high return from both a solar and storage perspective, One of the first things that we can start to do is visualize some of that LMP data across the US. As I engage this LMP data on the map, we'll start to see a heat map view of the different pricing. Right now, we're taking a look at that average LMP colored from lowest price node in blue to highest price nodes in red. And we can just get a sense of what the different pricing looks like across our map extents. But if I go back into this edit order layers dropdown, we'll be able to adjust what we're actually coloring that LMP data by. So we take a look at things like line loss, the congestion components of that pricing, but then we also break down the LMP by things like the maxes and the mins, the spreads, on and off peak hours. And then we actually do a historical look at a production cost model of what a solar or wind asset would have actually settled at those nodes. So since we're developing a solar project, let's take a look at this average solar weighted LMP across our map for our coloring of these nodes. On our dashboard, we can add in visualizations like bar charts, bubble charts, heat maps, pie charts, radar charts, scatter plots to actually analyze this historic data and drill down into the exact information that we want to see and the exact nodes that we would potentially want to interconnect at. We currently already have a couple LMP focused charts and visualizations on our dashboard. Two scatter plots here on the left-hand side of the page, we will actually repurpose to take a look at some solar and some storage related metrics. This top chart here is showing our average LMP versus the state and providence that those nodes are in. If I hit this little pencil icon up here, we can actually edit the data that we're viewing within this widget. So let's keep the state and providence on the x-axis, but instead of taking a look at that average LMP on the y, let's just type in that solar weighted LMP that we care about. Now that we have that solar weighted pricing on the y-axis and our states and providences on the x, we can get a little bit more understanding of where specific states are pricing, what that average is, and then we also have a little bit of a candlestick statistical analysis in this as well. I'll actually bump the number of categories here from 25 to 50 to show us most of those states across, and we'll notice that these are in descending order from the highest priced nodes that are located in Washington, D.C., all the way to Wyoming with that lowest average across all of the different states. So I'll just save this to our dashboard now, and we can edit that second chart that we want to see. I'll hit the pencil icon on this, and what this is showing us right now is the average congestion versus the average LMP across all markets. So we can just see some trend lines here, do some analysis on this. But for our specific project that we have in mind, instead of taking a look at that average LMP and the congestion, I'll flip the x-axis to show the state and providence again. And then that y-axis, I'll actually use one of our storage focus metrics, or storage arbitrage potential, to drill down into sites that have better availability for storage. And I'll bump this to 50 again for our max record count and save this to our dashboard. Now that we have some pertinent visualizations in our workbook, we can actually use these to ingest only the data that's going to be sufficient for our project. If I hit this little filter button at the top of the page, we'll actually be able to filter down to these nodes that meet a specific requirement for our site. So for this example, let's just say that we want a node that is greater than $60 per megawatt hour, priced in the real-time market past 1 year. As I let that filter go, we'll see that all of the other charts and visualizations update to just what was in that selection. And we'll also see on the map now that we're drilling down into only the nodes that met that requirement. So we've completed this for the solar weighted pricing, but now let's take a look at that storage arbitrage potential as well. As I use this selection, I'll give a little bit of a less strict constraint on that storage arbitrage potential, since this is primarily going to be a solar facility. Now that we've put some restrictions on the LMP data that we're viewing on the map, let's do some analysis of how many nodes that we've drilled down to. So it looks like there's still just under 5,000 different nodes in our map extents that we've identified as good project locations. In order to drill this down a little bit more, we could put some tighter restrictions on that data, or we could look at things like markets that we want to play in, specific states, counties, and drill into the data that way. For today's example, what we'll actually do is come into the filter panel on the right-hand side of the page, and under this ISO tab, we'll just take a look at data points within the SPP market. Now it looks like we've drilled down into mostly southern SPP with some generators that are settling into ERCOT as well. And then we see some nodes in North Dakota. But what we can do now is actually use some of those energy community layers from the Inflation Reduction Act to do some prospecting on which nodes may have some increased benefits. So this first layer I turn on is going to be our coal communities, showing all of those census tract areas that will receive added benefit to developing projects on. So it looks like we do have some overlap with our nodes in this Louisiana area. We have some in Arkansas, and then we've got some overlap in Missouri as well with those nodes and those coal communities. We can also turn on our EPA repowering areas, as well as our utility scale brownfield sites. And what I'll actually do is I'll just turn off our LMP data set real quick, and we can take a look at all of those different areas identified by the Inflation Reduction Act across the US. If we go into one of these areas, I know we saw some nodes that overlapped with this in Louisiana, and we click on one of these specific items, we'll be able to see why it's identified as a qualifier. So this specific area that I clicked on is directly adjourning a coal community. And we can see the same thing for utility scale brownfields. We can see the energy communities for the EPA repowering plants as well. So I'll just turn those off since we're taking a look at some mostly energy communities for coal here. And then I'll turn our LMP data set back on. And I'll make these points just a little bit larger for our actual LMPs. Looks like we have 4 LMP nodes that fall within this energy community. So what I'll actually do now is just take these LMP nodes and do a geospatial filter from the coal community. So I open up that geospatial filter. We can select what layer we want to filter around. We want to be within that energy community for coal, and then we can choose a distance. So I'll actually set this to 1 foot, and now we'll just consume the data for those LMP nodes within that energy community. As I hit save as area of interest, we'll see the data set for those LMPs get cut down to just those ones that fall within the distance. And now we can turn off that energy community. Opening back up that legend to look at the spreads of these nodes that we have in our map extents, it looks like these nodes are spread out between $60 per megawatt hour all the way up to $64. So the spreads are pretty tight in this region, and we can really look at all of the infrastructure around here from a transmission and substation perspective to build a potential project site. But one thing that we can do before taking a look at some of that data is actually expanding on the LMPs and seeing how these are changing time over both market prices and do a little bit deeper of analysis. Here we see all of those different data metrics that I had mentioned before over both pricing types and all date ranges. So we see those averages, the maxes, mins, the solar wind weighted pricing, things like our node to zone basis differential, and then we can also take a look at line loss and congestion. So doing a little bit of analysis on this, we see that that average solar pricing has changed in the past 5 years average from $42 up to $61.2 in the past 1 year. So we can do some analytics on this, see what the line loss, the congestion components are, the node to zone basis differential, and do some analysis to see if we actually want to build in this particular region. Another thing that we can do within this LMP card is go down into this hourly export tab and get CSVs of both the real-time and day-ahead data if you want to do any analysis outside of the platform. Going back to the 4 LMP nodes on the map, we can repeat this process to see if there's any nuance between these different nodes or to see if they follow the same market trends. To To speed up the process for today's call, let's just assume that all of these nodes follow the same trends as the one that we took a look at. The next two items that I'll turn on to our map is our substation infrastructure as well as our transmission lines. As I turn these two items on, we'll see them start to render transmission lines by the kV level, and then our substations just colored by our state and province. I'll actually just turn off our LMP nodes for this portion. Drilling into this infrastructure data a bit more, we can see a heat map view of the different voltages of these lines. And drilling into this data a little bit more, I'll open up the legend again, and we can see what the different voltages of these lines are, from low voltage in blue up to our high voltage lines in red. But in this region where we saw those high pricing metrics, I'll just click on one of these lines that go in between those two substations, and we can see details like what voltage it is. It's a 138 kV line. We can see who the transmission service provider is, Southwestern Electric Power Co-op, who would you would be coordinating with when you're going through the interconnection phases of the project. And then we can also see the name of that transmission line. On the substation side of the data, I'll click the layer that we're taking a look at to just those substations, and we can see some details about what that substation name is, what the status of the substation is, primary voltage, secondary voltage, as well as that total nameplate capacity that the substation has available. And then here again, we also see who that owner is of that substation. So we see that Southwestern Electric Power Company also owns the substation that the line is interconnected to. If I hit the details button on this substation, what will happen is it'll bring up a substation card that looks very similar to that LMP card. We'll see some of the data surrounding this substation, as well as the data of all of the generation facilities that are currently interconnected into that substation. But instead of looking at that, what I can actually do is turn on those generation facilities, both operationally and queued, and view them, visualize them on the map. So I'll do that, and I'll turn off our substations for just a second. Now that we have our generation facilities displayed on the map, we can take a larger county view, 510 county view of what's going on in this region, who's doing what where, and when it's actually going to happen. We can see the different colors of these projects that are displayed on the map, and if I open our legend, we can see these are various statuses from pre-construction, operational, system impact study, suspended projects, projects that are currently under construction, and those that are in interconnection agreement as well. With the granular level data that we're collecting on each one of these projects, we can create charts and visualizations to understand things like who the top developers are in this region, the different project types that are being built or operational, and then we can also see the different statuses, timelines of these projects as well. So if we want to dive into what operational facilities are in this region, we can see exactly where those are located. Mostly natural gas, about 1,000 megawatts. We see some biomass projects, and then we see 1 megawatt of solar facilities as well, and exactly where those projects are located. From a development standpoint, we can start to identify everything that's in the queue, who's building it, where it's being done, and gain some understanding of what the future generation landscape looks like in this region. For each one of these projects in the map, we can dive into the data a little bit deeper to qualify this region for either areas that we want to avoid developing in or avoiding the region altogether. So as I click on that particular project up to the north of our map extents, we'll see some high-level details on it. Things like project name, capacity, status, developers. But if we expand these details, we'll see a full picture of what's going on in this site. At the top of this page, we can see what that first queue date was, when it's planned to be commercially operational. We can see some location details on this particular project, and then we can see all of the supply chain entities involved. People like who the developers and owners are, if that ownership has changed hands, if there's public available information on power purchasing, who that power purchaser is going to be, including things like the megawatt capacity and the number of years that agreement is for, as well as tracking information on who's supplying different elements of the site and who the EPC is. To the right of that information, we can see the substation tab. Here we're going to be able to understand what particular substations a project is interconnected at. So here, this facility is interconnected on a transmission line in between the Lieberman and North Benton substation. And then scrolling down a little bit here, we can see information like the regulatory organizations, the docket numbers, and then our tracking of the specific statuses of each one of these projects. We also capture documents for these specific facilities. So in this particular project, we can see the facility study. We can actually download that, view that, read through it, and understand what kind of engineering design is going behind this facility, or in the SGIA, if there's been any system upgrade costs assigned to a particular project. We also capture notes from our analyst team who are going through doing primary research on these projects to update you and let you know exactly how we're getting this information. We track any news articles, press releases on these projects, any key company contacts. For every single operational facility, we'll have production data on how many megawatt hours that facility produced in a given month and the resulting capacity factor. And then we'll also have our economics data for every single wind and solar facility out there. So here we can see what that after-tax LCOE is and what we can use this for on a greenfield development workflow is to really understand how the competition projects line up versus the nodes that they're interconnected at to help you make that decision of whether you should build in a certain area or not. Or this can be leveraged in M&A activity, helping you to prospect for specific projects to acquire. So using all of this data for the generation facilities that are currently operational in a region that you're looking to develop, as well as all of the queued facilities, you can start to do some qualitative and quantitative analysis on these particular projects and determine whether or not you want to actually develop in this region or whether you should look elsewhere to build a project. After we've qualified a given region based on those things that we've taken a look at already, like pricing, like the substation transmission infrastructure, all of the generation facilities that are queued and operational nearby, the next thing that we can do is take a look at the parcels that are nearby. Who owns the land that we actually want to develop on? So as I turn those on, we can see these are colored by solar capacity factors. But if I flip this over to our buildable acreage percentage, we'll see a heat map of all of the parcels that are greater than 5 acres large. What's the least buildable is in blue, and what's in the most buildable category is in our red color here. To calculate out the buildability of each one of these parcels, what we're doing is we're taking into consideration things like the slope, the floodplains, the wetlands, the canopy coverage that crosses over each one of these parcels. So as I turn these exclusion layers, we're actually able to analyze any one of these parcels to see where that canopy coverage is over 80%, where there's a 100-year floodplain, where we have any slope over 5% is rendering in purple there. And then we can see where the wetlands run as well, rendered on the map. So as we're diving into each one of these parcels, we're able to identify exactly what's affecting it from a environmental constraint perspective. What I can do now that we're looking at this particular region is utilize that geospatial filter again and buffer around the transmission line or the substation for interconnection that we're looking at. So our layer is already selected on that transmission line, and we see a 1 mile buffer around this specific area of interest. So if we were wanting to interconnect into this particular transmission line, now we'll just consume the data surrounding that area. Since we are looking for some pretty large parcels with that requirement of being a 50 megawatt facility, I'll go here into our parcels tab in our filter panel, and under our acreage, I'll look for any parcel that's above 400 acres large. Another way that we can get down to the proper parcel size is query all of the parcels that we have in our map extents by owner and look for contiguous acreages. So as I pull this open and save this to our dashboard, instead of looking at who the developers are of a specific generation facility, now we're looking at owner sized by the amount of acreage that they have. Looking at the largest owner up here, we have Atheon Energy Operating Company. Taking a look at a couple of these parcels to the south, we can turn on our environmental layers to determine if any one of these are going to be better than the other from a constraint perspective. The first layer that I'll turn on in our exclusion layers, and actually looks like those are all already turned on, and we have a lot of environmental constraints across here. We've got some wetlands, we've got some slope constraints, we have some canopy coverage as well. So if I start to toggle these on and off, we can see what is primarily affected. So thinking about our canopy coverage, our slope, and our wetlands now, we see our 3 parcels that we're analyzing. And 2 of them seem to look better off. So we have the parcel in plot 15 here and the parcel in plot 12. So considering our tolerance for building in floodplains and all of the extra permitting and construction risk items, as well as operational risk items, we can determine whether we want to move forward with designing a facility on one of these particular parcels or moving and looking in another area for somewhere that's less affected by floodplains. Even with these floodplains constraints on this particular parcel, let's move forward and see what kind of analysis we can do as far as setting up the second portion of our call today on how we actually design a facility at this particular location. Essentially, what we need to determine to move our project into the design phase of development is where on the site are we going to restrict construction, where do we want to have available areas, as well as where are we actually interconnecting. So as we're looking at this, we can see that we have some slope, some canopy, and some wetlands that run along the eastern border. So what we'll actually do is set this as a restricted area, as something that we're not going to design around in the pvDesign platform. And then we also need to understand where our point of interconnection is. So we have a couple different options for our interconnection. We have this 138 kV running at the southern border of our parcel boundaries. And then if I back out of this view, we can also take a look at where the substations for interconnection are going to be. So I'll hide our exclusion layers real quick, and we can see that this parcel in plot 12 is in between the substation that we took a look at earlier, the McDade substation, and then also nearby is the Capless substation. One last item that I want to double check before we move forward with the actual design of this facility is if there's any other oil and gas infrastructure on this parcel due to it being owned by Atheon Energy Operating LLC. So what I can do is turn on our wells data set on the map, and this is going to show us exactly where there's any oil and gas wells. The wells that we have displayed on the map are currently colored by the region, but if I wanted to flip this around and change this into the status of the different wells, we can see which ones are producing, plugged and abandoned, inactive, or just drilled. As I flip our maps view from dark mode to satellite, we'll likely see some of these pads where these wells were previously drilled. Now that we know that this plot of land is very active in the oil and gas industry, what it allows us to do is build a business plan around that information, incorporating things like powering wells or coming to some other mutually agreed upon situation in order to build a solar plus storage facility on this property with their current infrastructure. But from a design perspective, it's very important to know where these specific items are located on the site. Both our floodplains, wetlands, slope, canopy coverage, this existing oil and gas infrastructure as we actually design the facility. So all of this information is exportable from our platform and can be directly plugged into the pvDesign platform as we're actually designing, optimizing, and completing an energy yield model on this piece of land. So as I click on this parcel, we'll be able to expand the details of the parcel and see things like what that parcel ID is, how many acres it is, who the owner is, the owner's mailing address. But one very important button here is this copy to pvDesign button. As I do this, we're going to copy a unique ID of this information and be able to import it directly into the pvDesign platform so that we can complete the rest of the design and engineering of this facility. So now that I've gone through all of this information in Prism, I'm going to hand it over to Angeliki, who's going to walk you through the actual design process within pvDesign.
So hello, everyone. Thank you so much, Jim. I will be continuing the process that Jim started here directly in pvDesign. I will be showing you how we can reduce the steps when we want to start working on a design and in the process of creating a site here in pvDesign. So I will be accessing the software from here, and then I will be accessing my project file here, and then I can create a new design. I can do so by clicking on the button here, Start Design. And as you can see, the software warns us that we have to create a site in order to view a layout and before generating a design. So the software gives us two options. We can either create a new site or upload a KML file here. So for this case, I will be creating a site and I will be transferred directly into the site creation tool that we have here. And as you can see, we have here 4 requirements that we need to define in the site here before being able to save our site. Okay, so we have to define at least one available area, our access point, a substation, and a medium voltage point. I will be starting with the available area, which is the parcel that Jim identified and located in PRISM earlier. So in order to import it directly here in pvDesign, I will be clicking on the import elements dropdown here. And here you will see the option of importing the parcel from Prism. And this is where you will paste the ID of Prism parcel, and you can click on import here. So now we have the parcel inside pvDesign, and it also matches the parcel from our external layers tool. You can access to this tool if you click on the right sidebar here on external layers, and if we enable this option here, you can see the rest of the parcels, and also if you click on it on the parcel, you can see some additional information. So I will be disabling the rest of the layers for now, and I will go back to my site elements in order to define the rest of them. So I will be creating here now, I will be adding the access point here. And in case you want, you can also add a secondary access point. You only have to click here on the place mark and choose the option of secondary access point here. And the access point will connect the roads with the point of boundary closer to the AC point. And we'll consider that there is an access gate in the bill of quantities. So visually, we will see that the roads connects with a boundary through this point, and we will see in the bill of quantities that an access gate has been considered. So as we saw before on Prism, there are restricted areas, and those restricted areas are things such as gas and oil infrastructures, any wetlands or high slope canopy. And we have access to to those restricted areas, and we can directly import them inside pvDesign. So for doing so, I will be clicking on the option of importing elements again. And now I will be clicking the option of browsing the file of my files here, and I will be choosing the file of restricted areas, and I can import the elements here. So now we see the restricted areas are defined. And so before in Prism, we were also able to see an existing overhead line. So let's assume that we want to build a new overhead line and land it on that same point of interconnection. So we can also upload that overhead line too by following the same procedure as before. I will click here. I will upload my file of overhead line, and we will see that it will land on the same point of interconnection here. I click on import elements, so it's imported, and I can continue now defining the rest of the requirements that we have here. So I will continue by drawing here the substation. So something important to keep in mind is that the starting point of the overhead line needs to be inside the substation. I will add also the medium voltage point here. And in case you want to add any batteries, you can click on the polygon here, select batteries area, and you can also draw your battery here. I will be adding also the medium voltage point here. And now we have all the requirements ready, and we are able now to either save this site as a draft so that we can continue working on it later on, or save it as a new site. So I will be saving it here as a new site. And it will be imported directly into my workspace and design process so that I can start working on it. So as you can see here, we already have a preliminary layout, and I can, if in the future I want to edit this site, I can do so by cloning. So I can click on the option here of cloning the site, and it will open the site again in the site creation tool. So I can do any modifications as I want. Or you can also download the file in case you want to view it in external tools. So from here, you can start working on the inputs values, and you can go back and forth from all the tabs here, and modify the inputs values until you reach your target power. And when you finish, you can come here and click on the Generate Design button. Here you can name your design, give it, and also choose the unit system that you want it to be, and also choose the language that you want your documents to be generated. So when I click here, and while my design is loading, you can see here that once my design is generated, I can clone it as many times as I want, so that I can have as many iterations as I want, so that I can test different parameters and see what's the best for me. I can also use the feature of comparison, so that I can compare more than one design and take insights out of them. So when the design is generated, I can click on it, and I can see here the final layout. And also here I can access to the 3D view of the plant, as you can see. And here on the top, if you click on the documentation drop-down, you have access to all the documentation, and you can download any documentation that you want individually, or you can download all of them. So that's the process here in pvDesign. So thanks so much for attending, and remember that if you want to know more about the tools and the solutions that we're offering, you can go to our website, to ratedpower.com or to enverus.com, and learn more about the solutions we're offering there. So again, thanks so much for attending.